So yesterday we started doing tan, and I introduced A and B to you. Today I'll introduce, or really reintroduce C and D to you, okay? And sorry. You're going to find that just like yesterday, I think you saw A and B did the same things to tan as they did to sine and cosine. C and D are very similar as well. Okay, so really good lesson, I think. Good examples, great short homework, concise. If you understand everything today, you really understand tan, which is, you're going to see, I think, pretty easy. Okay, so we're going to graph these two. Let's first, it's kind of my method is I like to identify all the variables first. And so A, of course, is 2. B is the number in front of X. C we haven't met yet, but C is coming up with X. We'll see C in a minute. If you want to take a look down here, that's where C would be, okay? We don't have one in this one. And D is the number all the way to the right, and it's going to take our graph down 1, okay? Then the next thing you want to do with tan is find the asymptotes, okay? So the asymptotes, if B is 1 and there's no, so our argument is just X. Let's just put it that way. There's no parentheses. The argument is X. The -1 is not part of the argument. So X is the only thing you would put between your asymptotes. So your asymptotes are just the parent function ones. And if you remember what those are, it's negative pi over 2 to pi over 2. So it is important that you guys memorize that tan's parent function asymptotes are from negative pi over 2 to pi over 2. And if we don't have an argument, it's not going to change. Okay? All right. We love that because now it's framed out for us. It's very clear where we're going to put our points. Don't forget this, though. D is new today, but you've seen D before. It moves your x-axis. It moves our x-axis down 1. So anytime you have a D, you want to put that on there before you start graphing. Instead of like putting the points and translating them all down 1, let's just move the x-axis, hypothetically, and graph from that. So now we're ready to go. We always have I called it an x-intercept yesterday. But let's just think of it, and I might slip up with the x-intercept, but it's a point dead center between your asymptotes, always. That's never going to change. And then between your middle point and your two asymptotes, dead center between those is where your other points will go. It's a positive A, so we know our points are going to line up as if we had a positive line, and it's up to 2. So I'm not going up to 2, I'm going to count up 2. So 2 from here would be 1, 2. It would be to the right. Same thing down 2 would be here. And then we squiggle. I was teaching earlier in the day, and it was a kid that was absent, and I heard him go, "Did she say squiggle?" I'm like, "Yes, I said squiggle. It's just my full word." Okay? And this repeats to the right and to the left forever. And we'll just follow directions when we get them. Does it say graph from 0 to 2 pi? Does it say graph 2 periods? So understand, sometimes your directions will be very specific. Graph from this theta to this theta. A lot of times it's 0 to 2 pi. Or negative 2 pi to 2 pi. Or it'll say 2 periods. And if it says that, you've got the one that you got from the original function, and then you could go to the right or the left. It wouldn't matter. Okay? Let's do another one. We have A is 3, B would be 1/2, and C and D we don't have, so I don't know why I was going to write that. Oh, I forgot. This asks for the period as well. So let's go over that, because I had questions about that all day today. The period is how much of the x-axis you use. This is important. Okay, so sorry, but I have to go back. How much of the x-axis or whatever x-axis that we use to make our squiggle. And listen, there's a lot of ways you can do it. Some of you, and I say some of you because not all of us are really visual. I'm not quite the visual learner. I have a hard time in geometry. Sometimes when they make really complicated shapes, I just have a hard time with like transformations, like dilations around the axis. It's just something that's confusing to me. I think I've shared that. These are, in my opinion, very visual. Like you could probably, most of you, just look at that and tell me what the period is. What is the period? Pi, right? Remember, it's distance. Half a pi plus half a pi is pi. But there's an algebraic way of finding it as well, or arithmetic-wise. So the period formula is the same as the one from sine and cosine. It was 2 pi over b. Now it's pi over b, okay? And also, you can find b if you have the period, because sometimes you're trying to find the period, sometimes you're finding b. They're good friends. It's just pi always on top over the period, or pi on top over b. So same exact thing I said to you with sine and cosine, except the numerator was 2 pi. That's the only difference, okay? So I could have said, okay, the period is pi divided by, what's my b? 1. Oh, it's just pi, okay? So whatever way works for you is fine with me. All right, so back to this problem. I identified A and B. Stop me if you have a question, guys. I identified A and B, and then I'm going to find the asymptotes. The asymptotes are really important. I wouldn't even begin trying to graph anything till I know where my points are going to be. So remember, I take my argument, which is whatever's in parentheses, take that, and I put it in between the parent function asymptotes, which we're memorizing is pi over 2 and negative pi over 2. And what, again, by the time I get to you, I've seen a lot of mistakes and stuff, so I like to share them with you. I'm seeing a lot of students struggle with how to simplify these. So I'm going to go kind of slow through it just for anyone that might be who hasn't said. But when you get to the homework with lots of time, don't be embarrassed, don't stress, don't struggle. Ask me. I don't know how to do this step, and I will help you. Okay, all you have to do is ask. Okay, so it's an inequality. We're trying to get x by itself. When we deal with fractions, for some reason we freak out. Okay, so this is just 1/2 times x. Multiplication. Opposite to get it by itself would be division. So I can divide everybody by 1/2, okay, including what's under my finger, my hand. So if I divide everybody 1/2, oh no, when I get over here and I divide a fraction by a fraction, I have to keep change flip. So instead of doing that extra step, let's jump ahead. Take a second and look. Divide by 1/2 or multiply by 2/1, which is the flip. So in this case, it's going to make more sense for me to multiply by 2/1, aka 2. And I'm going to do it to this guy. And oh yeah, I have an extra person hanging out with us today over there. Okay? And then I'm left with, in the middle, so these just cancel. I'm left with 1x, which is x. That was the goal. We needed x right there. And the 2's will cancel. You're left with pi. Understand, I didn't draw that very well, but it's pi over 2 times 2/1. That's what that is. So that's 2 pi over 2, which equals pi. So that's why I'm getting pi there. Same thing here. These guys cancel, left with negative pi. These are my new asymptotes. The b changed my asymptotes. It's a horizontal dilation by a factor of 2. It flips. It's going to actually make our asymptotes wider, as you can see, from negative pi to pi. They're wider than the other ones. The smaller this number is, the bigger the space is, the bigger the period. Okay, now that we have it spaced out, there's no d, so we don't have to move our x-axis. We're right in the middle. Same positive a, we're going to go right in the middle of these two. And again, if it's hard for you to see it visually, especially when we get into phase shifts and you have to put multiple on there, it might be harder to see where the middle is. So remember, you can do it mathematically. 0 plus pi is pi. Divide that by 2 is pi over 2. Okay? And I'm up at 3, and same thing down here at negative 3. Okay? And squiggle. What is our period? 2 pi. Okay? Pi to the right, pi to the left, 2 pi's, 2 pi. Again, you could do pi divided by b, keep, change, flip, multiplying by the reciprocal, 2 pi. So visually or mathematically, you choose what works for you. Good on those two? Everybody? Yeah? Okay. We're just going to do this one next. It's our first phase shift, right? We have A, we don't have a B, we have C. So A is negative 2 or 2 with a flip. We can call B 1. Sometimes I like to just identify it, but this is not part of the question. It's just me just organizing. And C, this is something we debate a lot. I called it fighting, but let's just call it mathematical arguments in my group of AP Pre-Calc friends. Some people say, let me back up here. Some people say this should be x plus c. Some people say x minus c. Most of us think that should be a minus to match all the other functions that we do. Because this is really like h and k. It moves your graph left or right and it's opposite. So when we write it like that, you always think of it as being opposite. So that's why I didn't really even talk about that too much. The truth is, in most of these, it doesn't matter. But let's stick with what we've always done, because that's what happens, and call this left pi over 2. And I'll explain to you what I mean in a second. You could call it negative pi over 2. You could call it left pi over 2. Okay? So either way. But that's what C does, and there's no D, right? And I'll come back to that little idea here in a minute. All right, we need asymptotes. B is 1, but we have something else in there. We have a C. C is part of your argument. So let's find our asymptotes down here. I have x plus pi over 2. Stick it right in between the parent function's asymptotes. Algebra guys, don't let the pi bother you. How do I get x by itself? Anybody? Tanner, tell me. Subtract. Oh, how do you get x by itself? You subtract. You don't always have to multiply and do fancy stuff. Sometimes we get to just do nice old-fashioned subtraction. Okay, so we're left with x right there in the middle, which is what we wanted. Right? Pi over 2 minus pi over 2, we got 0 over there. And a negative half plus a negative half is a negative whole. Whole what? Whole pi. Okay, that's negative pi. Right? 2 halves make a whole. They happen to both be negative, so our answer is negative. All right, so our asymptotes are from 0 to negative pi. Right? So phase shift is not scary. It's going to move our points left pi over 2 from the original, and I'll show you what I mean there. Let's put the points in. Right in the middle would be negative pi over 2. It's a negative a. Just pay attention to that. Easy points not to lose. Up to, down to here with the squiggle. I'm going to go ahead and put a second period on here. I'm going to go from 0 to pi, and I'm going to explain this to you real quick. So remember, this just keeps going and keeps going. So from our original equation, we went left, right? It's this one. But what if I just gave you this graph and said, pull the information off and tell me what the equation is? How would you have known if you went right pi over 2 or left pi over 2 just by this picture? You wouldn't. That's why it really doesn't matter with a lot of the movements, okay? So we're going to just kind of keep it as left pi over 2, and then we can make them anywhere. But if we were working in reverse, which happens in the homework, where you pull the information off and make an equation, you could have had a plus here or a minus here because you have no idea which one came first. Okay? Question? Example 7. We're only doing A, B, and C, and you might notice the homework number 5 parts A, B, and C exactly like this. Okay? So when you get to number 5, that's what I mean. Exactly like this. So let's just do this real quick. She broke it into left and right asymptote. We just do it as a compound inequality. So you can see A, B is 1/4. There is no C. D is down 2. But let's talk about the asymptotes. Asymptotes are going to be our argument stuck in between our... And remember, the argument is the parentheses. Who's hanging out with X? That's your argument. Okay, fractions again. Let's panic. X divided by 4. Opposite of division is multiplication. I'm just going to multiply everybody by 4. Do you want to put 4 over 1? Go right ahead. Okay, we're left with, I'm going to do this way. We're left with X right in the middle, right? Always cancel. We get 4 pi over 2, which is 2 pi, and same thing on that side, but negative. There are our asymptotes, the right one and the left one, if you wanted to split them up. Right? One on the right, one on the left. Okay? Period. what's the period? Well, a couple different ways you could do this, right? Some of you might be able to just look at that and say, oh, well, that's where my asymptotes are, negative 2 pi to 2 pi. How big is that? 4 pi, right? If you didn't catch that, remember, you have a formula. To find the period, we do pi divided by b. Keep, change, flip, you get 4 pi. So either way, perfectly fine. This last part of this question I love because it's giving us a chance to really show that we understand the language of functions. Like, you guys are able to look at this. I mean, it's kind of cool to get a geek out about it a little bit. Like, you all can look at where the numbers stand in the specific spots and say what it does to the parent function, which is y equals tan x. That 3 because of where it is, and that 4 because of where it is, and that negative 2, they tell us everything we need to know. And you guys are able to translate it and explain it in words. You are. I know you are. So, for example, the 3. Like, we'll say stretch by 3, right? Just quickly in homework or whatever. But let's practice the varsity language, the higher level language we want to use. So I would definitely tell you, you would want to say something about it being vertical, right? The A value is a vertical dilation. You could say stretch 100%, vertical dilation, and I like saying by a factor of 3. I like that word, factor. You're multiplying your y values by 3 to make them taller in both directions. Stretch out. Okay? We have that 4 in there. Anybody know what that is? What is that 1/4 doing to our graph in words? Say it again. Horizontal dilation. 100%. Think about it. I get excited. Whether it's a B value or C value in there, it changed our asymptotes. Here's the plain old boring one. We put a B in there, it widened. We put a C in there, it moved it to the left. So no, the C doesn't do that. Only B does that, sorry. C does move it left or right though. Okay, so if there was a C value, we'd say a shift or translation left or right. But we don't have that. All right, so horizontal dilation. Here we go though, by factor of what? No. 4. Anytime you're hanging out with X, it's always weird. Remember how it's like opposite left and right? Same thing here. Remember I said the smaller the number, and that's 1/4, the bigger it gets because it's really a factor by 4. And you saw that when you did it. And there's one more. The -2. Down 2, yeah. Can we zhuzh it up a little? A shift, I'm trying to think of what I wrote earlier, so because I was thinking exactly what Elizabeth just said. It's a one way of saying it, vertical shift or translation of down 2. I just got distracted. Sorry about that. But yeah, it is down 2, shift 2. I love for you guys to put the words vertical and horizontal in there. I think that's point worthy, okay? So if there was a C value, you would say a horizontal shift. It moves you, just takes the points, picks them up, moves them left and right. Just like up and down, takes all your points, moves them up and down. Good? Last question, I promise. Homework is shorter than the notes. Matching. Again, I love this whole lesson, but I love this problem too because it's just how much do you know about these functions? This is it. How little amount of work can you do to match these up? I want you to do a small amount of work. So instead of like going function by function, finding A, B, what are the, doing all that work and then matching the picture, let's kind of see what the differences and the similarities are. For example, both B and D are negative, where A and C are positive. So right there, I've got 50-50 chance, if I know that about the graphs. So which graphs are negatives? 3 and 4, right? These two have to be either B and D, right? These are B and D, have to be. And these would be A or C by default. So then I say, what's the difference between these two? Okay, they both have a D value. One's going down 2, one's going up 1. can't we just look at this and tell which one's got the points going down to? Yes, down to would be B. I didn't have to deal with finding asymptotes or anything. This one's going up 1, so that would be B. Okay, now I'm back to A and C. Let's see what's going on with those. Oh, look at this difference. 2 versus 1. One of them goes up to 2, one of them goes up to 1. This one looks friendlier. I'm going to look at this one. Dead center, right in the middle, it goes up to 1, down to 1. That's got to be C. And by default, this is A, but you might want to double check it. And I can't see it, but it is. Just can't see it. I don't feel like getting the glasses. Does that make sense, guys? Process of elimination, just like the quiz that you are taking on Quizlet. Nope, quizzes, sorry. It's just kind of process of elimination. A lot of those questions, 2 of them are signed, 2 of them are cosigned, so you should have a 50-50 chance, if nothing else. Okay, so homework is, unless you saw it that way. Pretty short. I don't think you'll have a problem finishing it. I'll let you guys get started, then I'll do the homework check. If you need anything, you have to ask. I'm happy, happy, happy. I want to help. Don't suffer. Don't think a question is dumb. Say it again? Yeah. I'll let you know. I'd have to look and focus. I don't remember what the last one was. Do anybody remember the last one I took? I think I'm in the teens. Did we all write the assignment? Good. Do we have that? Who said, wait. Yeah, it's short. You should be able to, everyone's had time in class to finish with time left over. Not to put the pressure on. wait, I'm supposed to say that. Okay, good, Arlen? I can fit all but one up, and then I'll put it. What? I can't hear. Oh, you're just rolling the dice. Yeah, you're going with your gut. It's important in gambling. No. Not that I remember. I don't really, I get a little intimidated at some of the tables. And everyone's like, you're a math teacher, it should be so easy for you. But I get stressed out about it. When people put that pressure on me, like, you're the math teacher, you don't understand. Like, figuring out tips, I can figure out tips very quickly, but I hate that everyone's like, well, can you help because you're the math, like my friends. Not Miss Shackton, no, she doesn't ask me to do that, which makes sense. But all my non-math, like, you don't understand how many people hate math.